I guess, yeah, seeing as it's about 20 past now, I can just kind of start. So you can see here from the first slide, this talk is for data science, so I should introduce myself. My name's Kiva, I'm a fourth year data science student here at DCU, and I'll be doing the data science talk today. See here the CAO course code is DC123, so when you're filling out your CAO, hopefully DC123 is what you put at the top. So maybe asking kind of what is data science? I knew when I started it, I had no clue what it was. So kind of from this Venn diagram, I think it explains the three major things. So the three kind of major components of the course is computer science, maths and statistics, and then subject matter expertise. And you can see there, there's overlapping with traditional software, machine learning, and traditional research. So all these skills combined together are all actually quite rare because the three of them separately can all be seen as different courses. Computer science, maths, they're both like separate courses. However, to have all these three together makes this course quite unique and really makes the students that come out of it very, very valuable, as not a lot of undergrad students have all these skills. So it's very unique. So just kind of further continuing on, what is data science? So data science is the use of statistics, computing and algorithms to get knowledge and insights from noisy, structured and unstructured data. So kind of an example of that would be the likes of maybe Twitter or Instagram that have billions and billions rows of data. And our job as data scientists is to kind of how to go through that data, take what's important, clean it, reduce redundancies, and make it really useful for the company or for clients like, advertising clients. Then what does a data scientist do? As I said before, then they use knowledge and insights from data to solve problems. They use algorithms to organize large amounts of information used to answer questions. So here then is just kind of the background and the requirements for the course. So we can see there the course title, as I said before, is Data Science and the code is DC123. It's 4 years full time and it's a level 8. It's based entirely in the Glasnevin campus, so there's no lectures on St. Pat's or All Hallows. So the minimum number of points is 499, however, that is kind of subject to change year on year. However, roughly for about the past 4 years, the maximum has been 501. And the minimum has been, again, 499, 498. So for the most part, the past few years, it has stayed in and around the same, but it can, of course, always change. Then we have a program-specific requirement. So this is kind of what differentiates us a little bit from the other computing courses, computer science or computing for business. So there is a minimum of a H3 in mathematics. This is just due to the high volume of maths we do in first and second year. With the likes of, we do these maths modules with the financial maths students and the actuarial maths students. So just a higher level, a higher understanding of maths is required. However, it is completely achievable. And then the DCU requirements, these are requirements for all courses. So a minimum of 6 subjects with a grade of 06 or H7. These then must include English or Irish and maths. Then 2 out of these 6 should have a grade of H5 or above. So then why should you become a data scientist? As more data becomes accessible, large tech companies are no longer the only ones in need of data scientists. The growing demand for data scientists across industries is being challenged by a shortage of qualified candidates available to fill up the positions. The need for data scientists shows no sign of slowing down. In the coming years, LinkedIn listed data scientist as one of the most promising jobs in 2021. So obviously if there's a great need for something, but not very many of them, like there's a lot of data science jobs, there's a lot of need with so many companies having so much data and not a lot of qualified candidates, we become quite kind of in demand, which is always what you want when looking for a job. So I'm going to run through kind of some of the modules. So when we say module, we just kind of mean like class or subject. So in year 1, we can kind of see that it's split half into computing modules and maths modules. So we can see here we have computer systems programming 1 and 2, an introduction to OR, and they all start from the very basics of computing. In introduction to OR, you of course learn the basics of OR, but in the other 3, you're looking at the very basics of Python, which is one of the most common kind of coding languages used worldwide. And then in computer programming 2, you're kind of using those skills and developing on them a little bit further. There's also data science and databases. So in this one, you kind of start to learn the fundamentals of machine learning and how large data sets are kind of broken up to reduce redundancies and how that's kind of used in real world application. Then on the math side, we have linear maths 1, 2, and then probability 1 and calculus and its applications. So you can see here, if you've gone to the computer science talk, you may have noticed that they have linear algebra and I believe probability and stats, which are only then 2 modules, whereas we go more into depth into both linear maths and probability and statistics, just as we need a greater understanding of it, again, for understanding the framework, the baseline frameworks for machine learning. Moving on to year 2, again, it's roughly more computing now than maths, but still plenty of maths. So we have developing internet applications, which is you develop a website using a program called Django. Then we have computer programming 3, which looks at data structures and algorithms, which is very, very useful when it comes to looking for jobs later on in the future and looking at your intra. They always ask this during job interviews to kind of explain why you would use certain algorithms, and this module covers that and some notes of that. I've used that a lot while going through the interviewing process. And then computer programming 4 is the first introduction for data science anyway, to have a look at Java. Then data warehousing and OLAP is when we really start to use the machine learning algorithms that we kind of learned the framework for when we were doing maths, and applying that to large data sets. We also then have an intro to machine learning, which again is kind of furthering our understanding of various machine learning topics and algorithms. We have then data processing and visualization and how we should kind of clean data and how to visualize it. Again, then we have programming for data analysis, and then again calculus, stats 1 and stats 2. Again, those are shared with the maths department. Year 3 is a little bit different. We have the choice of doing in semester 1 an Erasmus, which is you get the chance to do a semester abroad. However, I'll cover that a little bit later. However, you'll have these modules in semester 1. So we have data exploration using graph theory, application domains 1, where you get to look at large language models, kind of like what ChatGPT is. We also have a look at software engineering, professional and research practice. They're kind of looking at the best practices for software engineering and for gathering data, like ethically. And search technologies. So that's kind of looking at things like recommender systems, like how Netflix recommends you to do or recommends certain TV shows and movies to you. And the second semester is intra, which again I will explain later. And then year 4, again, we're looking at machine learning again. We're looking at how to use very large data sets and how to use them quickly. We're looking at building simulations, and again, natural language technologies, so large language models such as ChatGPT, kind of looking at that and how they work. We also have a final year project, which I will discuss now. So students undertake a 4th year project. It's 1 year in duration. The project is done in pairs. So some of the example projects, some of the ones they're looking at doing kind of in my cohort is the large language models, which is, again, like I was saying, kind of ChatGPT. So no one's building ChatGPT for their final year project. It's just way out of scope. But building a model where you ask it a question about football or whatever, and it will spit out an answer. Computer vision, which is what I'm kind of looking at doing for my project, which is teaching, I guess, the computer how to look at a picture and understand what it is and classify it in, it can tell you exactly what it is. Anomaly detection, so that could be something like a sensor looking up at the sky, and if it sees a comet, it would know to flag that's something interesting, that doesn't happen every day. And then predictions, anything that can happen in the future can be predicted. It's like stock markets, who's going to win the Premier League, who's going to win, the most golds in the LA Olympics, that kind of thing. And then there's a big expo at the end where you get to show off all your projects. So now I'm going to talk about intra. So intra stands for integrated training. It's the ability to get hands-on experience and the chance to work and build relationships. This happens in the 2nd semester of 3rd year, and that runs from January until August. So these positions are usually paid, usually minimum, but it depends on where the place. I did mine in PwC, and because I actually had the chance to do mine in PwC, that allowed me to have the experience that I needed to actually get a job in London. And a lot of these places as well often offer a job, like a return offer to you. once you've graduated to return there, once you have your full qualification. Yeah, so it's a really great opportunity. Not all colleges offer this, not all courses offer this. So it's really, really important though, and looks incredible on your CV to have 9 months of somewhere, especially working within your field. So here's some of the job opportunities that people from my course and other competing courses have had the chance to go through. So the likes of Amazon, Apple, Paddy Power, PayPal, I've kind of highlighted a few of those in yellow. And they're where some data science students have gone, computing for business, computer science. They can kind of go anywhere. Everywhere needs computing students. Now I'm going to discuss Erasmus. So Erasmus is an optional module in year 3, semester 1 of year 3. This basically means you get to study abroad for a semester. So from roughly September to December, you'd be in Lucerne University in Switzerland. So you'd pay DCU's fees, and then semester 1 exams actually take place a little bit later compared to DCU. They would actually take place after Christmas. However, this may be actually while you're on intra. However, intra places kind of understand that people sometimes do have to go back to finish exams. And any of my course mates who did go had no bother kind of getting time off work and going back to Lucerne and finishing their exams. Everything kind of worked out. And you can see that there's a general timetable of how the places are allocated. So there is a very kind of small essay portion of why you want to do it and that kind of thing. And it's also then decided on not only your application itself, but also your grades. So it's very important to kind of do well first and second year to kind of try to ensure your place in this Erasmus opportunity, because it really is kind of a once in a lifetime thing. And there's only been 2 years of it now, where they've had the chance to go over. It's a very new program, but it's really kind of invaluable. It's really amazing. Now I'm going to cover kind of very frequently asked questions that we've gotten either at other open days or things I myself struggled with before starting. So a question I get a lot is, do I need to know anything about coding? No, absolutely not. Coding is taught really from scratch. They do not expect anyone to have any background in coding at all. I know I had none. I was really nervous about coming in without having any experience. I didn't do computer science for the leaving cert or anything. But yeah, the teach from scratch computing has very quickly become my favourite part of the course, and I can say that same course-wide. Everyone really loves coding now. It very, very quickly became our favourite part. So then, are there any support for the maths modules? Yes, there are. The maths modules can seem quite daunting, especially when we're put in with the maths department. However, there are plenty of resources to help with this. So we have tutorials. So for each maths module, has a tutorial where there's a tutor who is usually a master's maths student or a PhD maths student, and they come in and something will be assigned by your lecturer, or you can go to them and ask them to kind of cover topics you're unsure about, that kind of thing. There's also the MLC, which stands for the Maths Learning Centre, and this is a free resource within the library where you can go, and there's students there, kind of very high level maths students, and they'll teach you topics you don't understand if you're stuck on assignments. You can go there. I think it's open most of the day in the library, totally for free. It's very, very useful resource. We also then have what's the difference between data science and the other computing courses, and in my opinion anyway, it's the amount of maths we do and machine learning. To my knowledge, the other computing courses have 2, possibly 3 maths modules, whereas we have a lot more for first and second year anyway. It really is a very large component of the course. It does kind of take up half your time. But this is really to kind of build a very solid foundation for understanding the machine learning topics later on, and just so you're really understanding why you should use certain things, why you shouldn't use other algorithms, that kind of thing. And again, as I was mentioning, the machine learning, we begin learning machine learning quite early on. We learn it start it in the first semester of second year. So we really have 3 solid years to have practical experience using it on different data sets and in different topics. Whereas I know for computer science, they only get the opportunity to start machine learning in the same module we do, in second year. They have it as an optional module in fourth year. So they just have a lot less exposure to machine learning. So if machine learning and kind of large language models, AI, that kind of thing, if that's what you'd want to get into, data science, I really believe, is the way to go, as you just have such more of a solid understanding of it, and you'd have more time to kind of really get into the nitty gritty algorithms rather than kind of surface level beginner things. I believe that's everything. If anyone has any questions, the talk will be going on for another about 4 minutes or so. However, if there's no questions, I can kind of talk. I can keep talking. I'll be here as well. This talk will finish at 6:40. However, I'll stay here for another roughly about 10 minutes and answer any questions that come through in the chat. So you have 15 minutes to get any questions in. I think before any questions come in, I think I see a few people typing. I can kind of talk, I guess, about Red Brick. So Red Brick is a club or a society within DCU that's very kind of closely linked with the 3 computing courses. Here we have. Is there a lot of teamwork in the course? There is I can very quickly actually run through which modules did have group work. So in year 1, from memory, in probability 1, you work in groups to do various assignments. So you're given basically maths homework and you work together as a group. I think that's it for year 1. There were other ones, but they've kind of been replaced now with more relevant modules. In year 2, in developing internet applications, there's 2 projects. So one is like a large group, there's maybe 4, and then a group of 2. There's kind of those 2 projects and that. Again, in year 2, I believe that's it for group projects. Year 3, again, there is actually quite a lot. I believe in everything except data exploration and application domains, those other 3, there are group projects, but you would have no larger group than 5. It'll either be between kind of 2 and 4 in most scenarios. And then for your final year project, that's always in pairs. That's in pairs regardless of whether you do data science, computing for business, computer science, all pairs. To my knowledge, there's teamwork, I believe, in all 3 of our computing courses. I think they really kind of try to highlight how important it is, to work together and to get to know your peers. In year 4, we did data speed and scale, had a group project. I believe that's all of our group projects. For year 4, there was just one small one. As you kind of go on, well, in data science, I guess actually less so. Most of ours were in year 3. But in most cases, as you go on, the groups tend to get smaller and you can tend to start picking them a bit more. So what are the main roles of a data scientist versus a software engineer? So in my opinion anyway, a data scientist is more to do with the data and getting the insights out of the data and how to properly interpret them, and then using machine learning algorithms, like for a task for like prediction, you might use whatever, algorithm A, B, C. Whereas a software engineer usually is a bit more about building a product. So say, for example, a software engineer for Amazon might work on like the Irish version of the Amazon, online shop, whereas the data scientist may look at the data that comes from this new website or comes from this new product and how it can then, be improved. And when you do projects, do you present in front of the whole class or just for the professor? This again depends completely on the module. I believe one of them we only just did the professor, most group projects there is a presentation involved, as the lecturers do kind of want to improve your presentation skills, because really in any job you go into there will be at some point you'll have to present either to a boss or to co-workers, that kind of thing. But they're usually never more than 10 minutes max. And really, since you're in usually a pretty large group of 3 or 4, it flies by. Absolutely, it flies by. So for like presenting in front of someone, I'd say kind of the best advice I could give really is to prepare beforehand. What we usually do, if we're in a group, we'll have a look, time ourselves, see how long everything's taking, and we'll also record ourselves so we can try and train ourselves to not fidget too much and not be going on your phones during the presentation, that kind of thing. Just because you could get marked down for something silly. Yeah, like we've had people, check phones in the middle of presentations or text someone back. It's a bit, just doesn't look great. I believe there's only very few projects, like your solo projects where you have to present. They can be a little bit more daunting, but usually if it's a solo presentation, it's a lot shorter. It might be 5 minutes, which again, you usually have so much work done that there is usually plenty to talk about. Yeah, if anyone else has any questions, yeah, please feel free to put them in. Yeah, I think again, yeah, there's a few people typing in their questions, so yeah, there's absolutely no rush on this. I'll stay here for another, I think, 8 minutes, and then unfortunately the chat does close in 8 minutes. But if you do have any more questions on UniBuddy, I believe we have ambassadors for all 3 of the computing courses. So if I can't answer your question, I can send you on to someone who can. I guess if I have, here we go. Is the job market for data science the same job market for software engineering? So for data science and software engineering, it is a little bit different. So they do expect, I think, different skills. I've found when doing interviews for data science, they not prefer, but are more interested in how you're thinking behind why you do certain things. So I'm using this algorithm because this, I'm trying this because this, explaining your thought process. And while it doesn't necessarily have to work, that's the whole thing with data science, it's a lot about experimentation. So as long as you kind of talk through, that's okay. But for software engineering, I think it's more expected if you're given a problem, you know how to solve it. Obviously, they care about your thought process, but if it doesn't work for the data science, it's almost a little bit more lenient, I've found. It is quite similar. It'll be a very similar pool of candidates. I believe it would be a little bit more difficult if you were from a computer science background to get into a data science job. Not all the time. A lot of places, a lot of graduate programs especially, would take the, software engineering skills you have and, develop on the data science ones from there. Vice versa as well. Like I myself know there's a guy in our course from data science, and he's got a job as a software engineer for Stripe. He got one for Amazon as well, but he accepted Stripe. So there is a lot of kind of transferable skills, a lot of the same skills, but it is ever so slightly different. Data science, I think data science, it usually requires more of a maths and machine learning background than software engineering. But if you did a computer science course, there's no reason why you couldn't get a data science, graduate role. Maybe a little bit more difficult, and you may need to kind of upskill in your own time and do your own data science projects. But for the most part, it should be doable. I think we still have another about 5-6 minutes here. If anyone else would like to put in any questions. Yeah, so we have Aidan here, who's actually another one of our brilliant computing student ambassadors. So he's just saying that he agrees with me here, and software engineering jobs mostly involve you solving a problem during the job interview and expected to have thought process while maintaining the functionality of the requested problem. So he's 100% correct here. It's, I think, more important for software engineers. Absolutely, I think that one of the best bits of advice I got for doing interviews was to talk the entire time, explain why you're doing everything. I know when I was doing interviews, I made some, terrible, stupid mistakes. But I explained why I was doing everything, and it may have only been something small, but they knew that, you're on the right track. So absolutely talk the entire time, really explain why you're doing everything. Like, you'll learn about it as you go on, but things like time complexity, space complexity are like really kind of good good buzzwords to know to make your code look as neat as possible, to make it run as smoothly as possible. Yeah, I think if anyone else has any questions, obviously put them in. We have another 4 minutes. I think I can very quickly no bother. I think I can very quickly cover red brick, because we actually do get questions about that quite a bit. So red brick is a society within DCU. I believe DCU has now over 100 clubs and societies, which is amazing. But DCU has a society called Red Brick. It's one of the oldest ones in DCU, and I'm personally not a member of it, but I've heard good things. So it can be really helpful to be a member of Red Brick, especially as you're starting out. Just because you'll get to kind of be surrounded by other people who've been in computing courses a little bit longer than yourself, and can kind of give really good advice for different modules and different projects and different topics that you might be struggling on. So yeah, we're just being told there that's going to finish up at 6:50. So I think that's really all I had to say about Red Brick. It can be kind of very good to join, and then you'll sometimes get a head start on maybe some of your other peers who won't have the experience that you gained in Red Brick. So I'll stop my video now, I'll mute myself. And if anyone has any questions, please contact me on Unibuddy. Yeah, thank you very much.